the light, that is in darkness, you cannot see anything. We are able to see anything when light falls upon that object, or whether light is emitted by an object or whether it falls upon an object. For example, sunlight emits the light, right? So you are able to see the sun because it emits light. It is a luminous object. And you are able to see a non-luminous object. Why? Because the rays of the sunlight that falls on it are getting reflected by it. That's why you're able to see the non-luminous objects as well. So light has a very important role to play here. Getting it, Ahmed? Okay.
Yes, sir.
Okay. So we also talked about like objects were of two kinds. One that can emit its own light, or one that cannot emit its own light. That were luminous and
Non-luminous.
non-luminous. Okay. Someone from you posed a question. I think it was Arhan or Arham, that whether a black hole is a luminous or non-luminous body. Yes,
I guess it was a, sir.
it was a non-luminous body. Good.
Yes, it's a non-luminous body. It absorbs the light.
Exactly. A black hole is formed now when a large amount of mass, a very huge amount of mass constricted in a very small space. एक बहुत ही छोटे से स्पेस में ह्यूज मास को हमने कंसंट्रेट कर दिया, then it leads to development of black hole, and it has got so much of gravitational pull. Gravitational pull is so much stronger that even light cannot escape from it. In fictional movies में, in science fiction, black hole कुछ इस तरह से दिखाई जाती है, right Ahmed? This is how
Yes,
black
sir.
hole looks like, but yet
Yes.
we don't have a very high pixelated image of black hole. So rather we see recently an image of black hole was formed, and it looked like this. So here you can see now, it looks like it is emitting light, but this light which you are seeing here, it is not the light coming from the black hole itself.
Black hole.
It is actually the dust, it is actually the star dust surrounding the black hole that forms the clouds. So dusts of stars forms clouds, and that clouds radiates energy. It radiates energy. So it is due to the radiation of that energy, you are able to see this color here. Getting it now?
Yes, sir.
Okay, so hence black hole was a non-luminous body. Anyways, so we started our discussion about light, and light possesses two nature, dual nature. What is the dual nature of light? What does it says?
Light's 12 nature, sir.
Mm-hmm.
Uh, I don't
Light
really
has
know.
got both particle and wave nature, no?
Yes.
Yes. Light has got a dual nature. Were you present in the previous class or not, Ahmed?
I previous classes, but I think I joined a little bit late.
Okay. So you joined late anyway. So I told you guys that light has got a dual nature. Light has a very weird nature. Okay. So it has particle also, it has wave also. And the particle of the light was called as photon. It does not have any mass but has got energy. Okay, then talking about wave, it travels in the form of electromagnetic waves. In short, you write it as EMW, electromagnetic waves. Short में हम ऐसे लिखते हैं. Okay. Few more interesting things about light. Light travels in a straight path or curved path.
Light's straight path.
A straight path. Good. How can we prove that light travels in a straight path? If you
The sunlight.
Yes.
It's just straight.
Okay. Sunlight travels in a straight path. Just by looking at it, you can't derive the conclusion. You can't make the conclusion. By an activity, we can actually prove it. Suppose you were to take a piece of candle here and light this candle and place some piece of cardboards. Okay. Let's place two cardboards here and make holes which are at the same height as this flame is burning. Okay. All right. So if you were to stand here, if someone was to look from here, suppose this is the eye of some person who is looking here. All right. So the person will be able to see the flame via this hole. Okay, Ahmed. But what if I were to place another cardboard here, let's say, and the hole has been made at a little bit more height. Here, the hole has been made here. So you won't be able to see the flame from this hole. Why? Because light is traveling in a straight direction here. Getting it, Ahmed? The light coming
Yes.
from this flame is traveling in a straight direction here. So it is coming in this way. It is not coming in this way. Getting it now? So that actually proves that light travels in a straight line. Is that clear?
Yes, sir, it is.
Okay. Okay. Why? Where is Arhan and Arham? They still haven't joined yet.
Yes, sir, they haven't.
Okay. No, lights. The speed of the light is 3 into 10 raised to the power 8 meter per second, which is very much faster than the sound. So light
Yes.
travels faster than sound.
Sound. The proof is the thunderstorm.
Exactly, faster than sound. Okay, and we can see things only because they reflect light into our eyes. So whatever you are seeing now, so we are able to see things because they reflect light into our eyes. So suppose there's a piece of an object here, for example, a piece of glass here. You are able to see this piece of glass because light rays coming from any source, it gets reflected to your eyes. Getting it now?
Yes.
Suppose this is the eye of a person. Okay, so reflected lights reaches your eyes, right? So we can say that we only see things because they reflect light into our eyes. Yes, no, yes, Ahmed. Okay, so these were the properties of light. Also, do tell me, is light a form of work, energy, or power? What is it like? Light क्या है? Ahmed, are you there?
Yes, sir. Light is an energy, sir. Sorry. I
Exactly,
think
light is a form of
energy.
energy. Good. Okay, and how shadows are formed? How shadows are
Shadows
formed? Mm-hmm.
by light and little bit darkness.
What are the conditions required for the formation of a shadow? Suppose this is a torch here, the torch which our grandfathers used to use, the old type of torches. Suppose this is a torch.
Okay.
Okay. And suppose you have placed a piece of brick here. Brick here. So you will see a shade is formed here. The shadow is formed here.
Yes.
Okay. Shadow like this might be formed. So what do you see here? The pathway of the light is being blocked by an object here.
Yes.
Right now,
Yes. Yes,
this
sir.
object is blocking the pathway of the light. So shadow will be formed whenever light is blocked by an
Oh,
object. Right now,
yes.
shadow of break. So we say that light is okay. Sorry, shadows we were talking about. Shadows are formed when light is blocked by an object. Okay. So,
Yes.
for example, if in case of brick, you had any other object. For example, if you were to have a piece of glass here, okay, will the shadow be darker or will it be dimmer? Will it be dim?
Uh, little sir.
Yes. So you see, this brick is an opaque object.
Yes, it is.
Yeah. Based upon how much of light can pass through an object, you have three types of objects. Yes, no? What were
Yes.
the three types of objects? Can you name them?
Opaque, non-opaque, and blur.
No, that is not the exact names of the types of substances. Based on how much light can pass, there are three types of materials. Okay, just give me a moment. Let me check if others are in the waiting room. Okay. So based on how much light can pass through the object, they are of three types. First one is opaque, where no light can pass. Then you have translucent. Okay, where you say almost 50% of light is allowed to pass. Then you have got transparent, where almost 100% of light passes. Almost 100% of light passes. Getting it now?
Yes, sir.
So those were the three types of classifications. So the type of shadow that is formed, it will depend upon the type of the material also. If it is opaque, a very dark shadow will be formed. If it is translucent, the shadow will not be very dark. Right now,
Yes,
if the object is transparent, there is no shadow formed at all. Okay, is that clear?
sir.
No, let's move ahead then. We were talking about reflection. So reflection, we discussed that when you have got a very smooth and shiny surface, for example, the surface of a mirror, it will reflect the light. Okay.
Yes, sir.
Reflection will take place from water surfaces also, and it will take place from irregular surfaces also, right? But there's a difference in the manner in which the incident rays and the reflected rays are formed. Getting it now?
Yes, sir.
So based on that, you have got laws of reflection, and laws of reflection we will be studying for smooth surfaces only. So there were two laws of reflection. How many laws
Two.
of reflection are there?
Two.
Two. The first law of reflection, it says that the ray it says that the incident ray that falls on the mirror is equal to the reflected ray. Getting it now?
Yes, sir.
Before that, do tell me, is the concept of incident ray and reflected ray are you aware of the terms or not?
No, sir. I haven't. Not. Okay.
Okay, let's first study about them, then that's better. Look here, whenever a light falls on an object, okay, the light that is falling on an object, for example, you take a smooth surface. For example, you have taken a mirror here. Okay, this is the surface that reflects light. Okay, and this is the back of the mirror, which does not reflect the light, which is the non-reflecting. Getting now? And it is
Yes.
polished with
No.
silver. So the mirrors which you use at home, the back of the mirror, it is polished with silver. All right.
Understood.
Nowadays, since silver is costly, so other materials are also being used to polish back of the mirror. So if you ever were to turn the back of the mirror, see the back of the mirror, you will see
It's.
that it is painted with red or blue right now. So if you
Oh,
were to scratch it using a piece of a blade or nail, so you will find that little pieces of silver will come out. Okay, very tiny scratches of silver will come out. But nowadays they use a mixture of paint, red or blue paints are being used. Anyway, so from the smooth side, the reflection takes place. And from the non-smooth side, you will be representing it like this by making shades. Okay.
yes, sir.
All right. So suppose a ray of light is falling on it. So the ray of light that falls on a smooth surface, that is called as incident ray. उसे हम क्या कहते हैं?
Incident rate.
Incident ray. So it is simply also also one more thing, like in mathematics you study about rays. Yeah, in your junior classes you must have studied about rays, lines, line segments.
Oh, yes, sir.
Yeah. Okay, so line is such a in line you have no endpoints. It continues to extend in both directions, while a line segment is a segment of line. आपने line का
Yes,
एक टुकड़ा लिया, that is called as line segment. While, for example, rays has a beginning point but no end point. It will start to begin from here, but it will continuously move in one direction. It will not stop. Okay, so उसे हम रेज कहते थे, right? ना उसकी origin का तो हमें पता हो, where it is starting from, you will be aware of that, but in where it will be going, where it will be ending, you have no idea. Okay,
yes, sir.
for example, sun, the origin of the rays are from the sun here. Okay, and it is moving in this direction here, right? So that is called rays. So that's why you call it as incident ray, that it has got a source, but where it will end you don't know it. All right, so the light ray which falls on any surface is called as what? It's called the incident ray. Is that clear?
Reflection. Yes, sir.
All right, okay, so see here, this ray will be called as incident ray. All right, now this ray will be getting reflected also, depending upon the type of surface it is striking. It will reflect also in a certain direction. So for example, see in this mirror, it is getting reflected in this direction. In the case of specular reflection, this is getting reflected also, while in the diffuse reflection it is getting reflected in random different directions. All right,
Yes, sir.
so you have a reflected ray. Okay, try to define it now. Define करें इसे आप.
Yes, sir.
Define a reflected ray.
Um, a, a light
Hmm?
that is
The light ray,
transferred to the opposite way.
not necessarily opposite way. Okay, in many cases what will happen now, if the light ray is falling perpendicularly at a 90-degree, light is coming in this direction and light
Yes.
will return in the same direction.
Uh,
Okay, so here you won't be seeing in the
Opposite.
okay, okay, so that will be becoming more confusing. So we simply say that the light ray that comes back from the surface after reflection is known as what? Reflected ray.
Yes,
Is that clear?
yes, sir.
Okay, so definitions exams में आती हैं. Define incident ray, define reflected ray. All right, so now
Yes.
you what is incident ray and you know what is reflected ray. Now this will be called as reflected ray. All right, now one more thing you need to know, what is normal here. Normal, it is simply perpendicular line that is drawn to the mirror. All right, drawn to the mirror or basically the surface. All right, so for example,
Yes, sir.
uh, uh, for example, you draw a perpendicular line, so that you will be calling as normal. So far everything's clear?
Yes, sir.
Okay, so do one thing, take the screenshot now.
Oh, okay, sir. Done, sir.
All right. Now let's talk about the laws of the reflection. Any confusions so far?
No, sir.
Okay. Laws of reflection इसकी हम बात करते हैं. Now, what are the laws of reflection? The laws of reflection simply says that the first law of reflection is says that before that one more thing, let me make it clear. You have this mirror here. This is the incident ray, this is the reflected ray, and this is the normal. All right. Okay, this
Yes,
is
sir.
normal, this is incident ray, this is the reflected ray. Now you will be seeing that the ray that is falling on the mirror will be forming an angle with this normal. यहाँ पे एक angle की formation हो रही है. You will be calling it as angle of incidence, theta I. ओके, बहुत ही स्मॉल एंगल बनती है, इसलिए इसे हमने थीटा के फॉर्म में रिप्रेजेंट किया. ओके, दैट यू विल बी स्टडिंग इन सीनियर क्लासेस, डोंट वरी अबाउट दैट. ऑलराइट. और इसे हमने क्या दिया, थीटा आर. और इफ इट इज गेटिंग कंफ्यूजिंग ना, सिंपली कॉल इट एज एंगल ऑफ इंसिडेंस और एंगल ऑफ रिफ्लेक्शन. दैट्स ओके नाउ. सो यू नो अबाउट
Yes,
दिस.
sir.
दिस इज एंगल ऑफ इंसिडेंस. ये किसके साथ फॉर्म होगी? Is it forming with the surface of mirror or normal?
Surface of mirror.
No. Angle of incidence किनके बीच फॉर्म होगी? It will be forming between the incident ray and normal. All right, Amit. ये incident ray और normal के बीच फॉर्म हो रही है, right now? This is your angle, all right. Many times the student confuses and they say that this is the normal, this is the angle of
Oh, yes,
incidence.
sir.
So always remember that angle of
Angle of
incidence is
incidence.
formed between the normal and between the incident ray, all right.
Yes, sir.
Okay. Do tell me, where will be the angle of reflection formed?
Or normal.
Between normal and between reflected ray.
Yes, sir.
Okay, it will not form a normal only. You need at least two lines to form an angle now.
Oh,
Okay. So this is your angle of reflection here. Got it now? Good.
yes.
So the laws of reflection, let's study about them. The first law of reflection says that the angle of incidence is always equal to what? Is always equal to the angle of reflection.
Yes.
Getting it now? So it simply means that angle of incidence is equal to angle of reflection. So इसे आपको याद रखना है. This is the first law of reflection. Now let's study about the second law of reflection, what it does says. इसमें कोई problem आपको? Is it clear?
Yes, it is clear.
Okay, good. Now, the second law says that the incident ray, this ray
Yes.
that is coming here at this mirror, and this normal, which is here, this normal line, and the reflected ray, this reflected ray, hmm, all are lying in the same plane. All of them are lying in the same plane. Which plane? This is the plane now, and all of them are lying on the same plane now.
Yes.
Is it getting clear? For example, this is the surface of the mirror. The normal line is also here. It is also on the same plane. It is incident ray is also on the same plane, and the reflected ray is also meeting at the same plane. This is your plane simply. Okay. It's not like कि normal यहाँ पर है. Okay. Incident ray is falling here. All right. And reflected ray is getting reflected from here. It's not like that. All of them are meeting at the plane. Is it making sense to you? Is it getting cleared?
Yes, sir. But kind of confusing.
Look here, the simple thing is now the incident ray, the incident ray, this incident ray here, this normal line here. See this angle of this incident ray here, or the normal. Look over here. All of them are meeting at the same point here. This is the meeting point. Look over here where I'm highlighting. This is the meeting point of the three lines here. Okay. Are
Yes.
they, and they are falling on the same plane now? Yes.
Yes.
Yes. Give me a moment.
Okay.
So you see, whether you talk about Ahmed incident ray, or whether you talk about angle of, or whether you talk about reflected ray or this normal, all of them are meeting at this point here, and they are lying on the same plane. It's lying on the same mirror now. It's not like that angle of reflection is somewhere else. Hmm? It is like this. This is a ray of incident ray. This is your incident ray. This is your reflected ray, and this is the normal line. And this is the point where they all are meeting, and they are lying above this mirror. Okay, and this mirror, it is a plain surface. Understand it like this. Okay, it's not like that. It's not like that. That incident ray is coming here, normal is here, or reflected ray is here. No, they all are meeting at the same point here and lying on the same plane. Is it clear?
Um. And yes, sir. Bit of.
A bit of. It will become clear. Yes, Arhan, what about you? Where have you been? Okay, so the second law of the law of reflection says that the incident ray, the normal at the point of incidence, and the reflected ray all will be lying where? All lie in the same plane. Yes, Arhan and Ahmed. The first law of reflection says that the angle of incidence will always be equal to angle of reflection. For example, if it is 5 degree, this will also be 5 degree. If this is 3 degree, this will also be 3 degree. That is the first law. You know where angle of incidence is formed? It is formed between the incident ray and between the normal. All right. And what about the reflected angle, angle of reflection? It is formed between the reflected ray and between the normal. That is your angle of reflection, and their value will be equal to each other. Is the first law clear to both of you? Yes. Guys, is the first law clear to both of you or not? Please be attentive in the class.
Yes, sir. It is.
Arhan, what about you? Talking about the second law, Ahmed and Arhan, second law simply says that you have this incident ray falling on this mirror. You have this normal which is formed at the point of incident ray. Okay, where this incident ray is falling on the mirror. From that point, you form the normal line. यहाँ पर हमारी इंसिडेंट रे फॉल करती है, ये पॉइंट है, this is the point here, and
Yes.
from here you will draw the normal line. All right, and this is a reflected ray. So simply the second law says that the incident ray, the normal at the point of incidence, and the reflected ray all lies in the same plane. For example, if you were to take a torch, if you were to take a torch, and if you were to light it on a surface, for example, if you were to um, light it on a mirror, so it will be getting reflected from the surface of the mirror now. It is falling on the surface of the mirror now. Yes, Arham, are you there? Yes, I guess I'm audible to all of you.
Yes, sir, you are.
Okay. Arhan and Arham, what about you guys? Why have you joined late today in the class? So Ahmed, please tell me, is the second law clear to you? And what about you guys also? Please do tell me, is the second law clear or not?
So the second one is kind of confusing for me.
Okay, okay. It is not cleared yet. Okay, look. Let's understand it like this.
Sir, am I audible?
Yes, you are audible now. Okay. Take the
Okay, sir.
screenshot. First, take the screenshot, and I will be repeating the second law of reflection. Okay. Do let me know when
Okay,
you
sir.
have taken the um, when you have taken the screenshot. Do let me know. Yes, done. Okay. Look here. The simple thing is now you have a mirror here. Okay. Suppose this is a mirror here. You have let it flat on the ground. This is a mirror. All right. Is that clear? Now, let's say this is this will be the reflecting surface. Now, I am trying to explain it in a 3D diagram. So say that this is the okay. Let's say okay. Let's say that this is the incident ray coming on the surface. Okay, and this will be getting reflected also, and this you will
Yes, sir.
represent as angle sorry incident ray, and this is your
Yes, sir.
reflected ray, guys. According to the first law, as you guys are aware now, that the angle of incidence and angle of reflection, their values are equal. This I is equal to this R. Is that clear? That is what the first law of reflection says that.
Yes.
Okay, second law of the reflection was stating that the incident ray, the normal at the point of incidence, and the reflected ray all are lying in the same plane. Now, when I say the term plane, is this normal? Is this mirror lying on the or lying on the ground? Is not a plane. When I say the
Yes, sir.
plane surface, what comes in? What picture comes into your mind? For example, look at the table, your study table. Look at the bed,
Sir, a plain flat
a
surface.
plain flat surface. So you see this incident ray, this normal and the reflected ray all are lying on the same plane. At this point O here, it is lying where? It is lying on the reflecting on this reflecting surface, that is mirror. Yeah.
Yes, sir.
Okay. So that is the thing here. One more thing here I want you guys to know here. Now, it is going to be a little bit it is going to be interesting here. Now, if you were to look at this figure which I have drawn here, this square which I have drawn here, see which I'm trying to highlight here, is that not also looking like a plane?
Yes,
Yes.
sir.
So if you assume this plane as a glass slab, or let's say it to be a paper, okay. Now, if it's possible, I would like to have explained this in with the help of a paper. Okay, anyways, in the next class it will be possible. Today actually I'm having technical issues with my laptop, so wouldn't be able to join with the laptop. So I would have shown you with the help of papers. So suppose now you have taken a paper here, just assume lying on the ground, and suppose you place another paper just perpendicular to it, hold it perpendicularly over it. Okay, are you able to imagine it? Yeah. Yes. Are you guys able to imagine it? So simply the thing is that this surface of paper is also a plane surface. Okay. And suppose the light rays are coming from here and you depict it as reflected ray and incident ray like this here. And this is a normal. So whether this is your incident ray or whether you have normal and reflected ray here, all of them are lying where? They are lying on this piece of paper now. It is not outside
Yes,
of the
sir.
piece of paper. It is lying on this paper. In the same
Yes, sir.
manner, this incident ray, this reflected ray and the normal are actually lying on this plane. This is also a plane. This is just a hypothetical plane which I have assumed here. Hypothetical word, you guys know what it means. Just हमने imagine कर लिया. Okay, so this is the hypothetical plane that is containing incident ray,
Sir, I'm the
incident
only
ray.
one in the class.
You are only here.
Yes, sir.
Okay, where are they? Okay, so look.
Ahmed has left.
Okay, do let me know when they join. So hypothetical, this is the hypothetical plane Arham and Arhan, and it contains incident ray, it contains reflected ray also, and it contains normal also. Getting it now? So that is what the second law of the reflection says, which it simply said that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. Is it clear? Mm-hmm.
Yes, sir.
Okay. Yes, has Ahmed joined?
Arham has joined.
Arham has joined. Okay. Now, let's move ahead then. The first two laws we have covered. Is it clear? Arham, is it clear to you?
Sir, he has just joined, I guess.
Okay. Let him join with the. Let him join.
Assalamu alaikum, sir.
Walaikum Assalam, Arham. Arham, where
Yes,
have
sir.
you been? Why are you so late?
Sir, I was not joining today. I just wanted to say, I'm going to say now. I just wanted to ask you something that
Mm-hmm.
on Saturdays,
Mm-hmm.
in the evenings, I'm usually out, so I'm not able to attend the meetings. So
Mm-hmm.
can you just shift me in the morning, but just for Saturday?
On Saturday,
Yes, sir.
you are not able to attend the class in the evening.
Yes, sir.
Okay. So you were saying something that in the morning. Please,
Yes,
please
sir.
do repeat.
Please shift me in the morning batch in Saturdays. 12:30 might be okay.
Okay, 12:30.
Yeah, in your standard time.
Okay. Are you asking for the test series that is going to be conducted on Saturdays?
No, sir. Normal classes on Saturdays.
Normal classes on Saturday.
Yes, sir.
Okay. We will see to that and you will be updated regarding that. Okay.
Okay, sir.
Okay.
Yeah.
Okay. So are you going to continue in today's class or not?
So what have you done?
We were talking about the laws of the reflection. The first laws of reflection and the second law of the reflection. There were two laws of reflection.
Yes, sir.
Okay. So you have this incident ray and this reflected ray.
Yes,
Okay,
sir.
this is the angle of incident, this is the angle of reflection forming with the normal. So first law basically states that the angle of incidence is equal to angle of reflection. Okay.
Yes, sir.
And the second law basically says that the incident ray, reflected ray, and normal all lies in the same plane.
Yes, sir. Sir, have I missed anything?
Okay. You should join the class at the given time, no, guys? Raham,
Yes,
try
I'm
to
trying
join the
my
class at the given time. Okay, no issue. So you haven't missed much. We were talking about this, and earlier before that we talked about that
This
how
is
shadows are formed. Yeah,
These are all the things done yesterday, right?
yeah, we have done that, but few more things we discussed today. For example, how shadows are formed. Shadows are formed when light is blocked by an object. Okay,
Yes.
and depending upon the object, like you have three types of objects: opaque, translucent, and transparent. Right?
Yes.
No need to explain that. So
Yeah.
shadows will be formed differently for opaque objects, translucent, and transparent objects. Right now.
Yes, sir.
So that was the thing we discussed before you joined. Now let's move ahead, and you guys have got a question here. A smooth shining surface which rebounds a light back in same or different direction is called as what?
Reflection of light.
Reflection of
Yes.
light. Is
Reflection of
that the
light.
answer?
Smooth shine. No,
No,
no, no, it's the mirror, sir.
it's the mirror. No,
Yeah. It's the
Arhan.
smooth shine.
Oh yes, yes.
Yeah, we are talking about the surface now, not the phenomena. Yes, is Ahmed here or not? Okay.
He is here, I guess. Yes, sir. He is.
Okay. Okay, guys, look at the question. Maximum part of light is reflected by what? Is it by opaque object, translucent, transparent, or all of these?
Sir, opaque object.
Opaque object. What about you, Arhan?
The transparent object.
Transparent. Okay. Ahmed, what
Since
about
mirrors
you?
are transparent.
Okay. Ahmed is here or not?
No, sir.
He is here.
Yeah.
Okay. Ahmed, do tell me the answer. Maximum part of light is reflected by what? Arham, by the way, you answered which one? The first one.
Yes, sir. Opaque object.
Okay. What about you, Arhan? You answered transparent.
Yes.
Ahmed, what about you? Quickly give me your answer. Okay, look here. I'm not getting a response. Look, the thing is now, the answer opaque object is correct. How come transparent objects reflect? If you
Yes,
have,
the
if
light
you
will go
have
through.
got, exactly, if you have got a transparent object, the light will simply pass through it now. Okay, but if you were to look at an example of an object of opaque object, for example, this mirror, the back of the mirror is polished with silver. It is polished with silver. Nowadays,
Silver.
it is painted with red color, and there's a very thin layer of silver beneath it. So light
Yes,
is
sir.
not passing here. Light is getting reflected from the silver here. It is getting reflected.
Yes,
Getting
sir.
the guys. So that is the thing. Okay, Arhan. The
Yes.
perpendicular, the perpendicular drawn to the reflecting surface is called as what?
The normal, sir.
Normal. What about you, Arhan?
The
Ahmed?
normal.
Normal.
Uh,
Yes, Ahmed. Do you differ, or is it normal?
so I was about to say incident.
Yeah. The answer is, the question is perpendicular drawn to the reflecting
Normal,
surface.
sir.
Normal. Okay. And also to tell me the angle of incidence, will it always be equal to the reflection, or will it be sometimes equal to the angle of reflection,
It will
or under
always same.
special conditions? It will
Always be equal.
exactly. Angle of incidence is always equal to angle of reflections, no matter what.
Reflection. Yes, sir.
Right. Now let's we
Yes,
will be
sir.
studying about the properties of image that are formed by the plane mirror. right now?
Yes, sir.
Okay,
Yeah.
Yes,
okay.
sir.
Before that, I've got few more questions. How many laws of reflections we have studied? How many of them are?
Two.
Only two laws. Okay. The first
Yes,
law
sir.
states that angle of incidence is equal to angle of reflection, no matter what the situation is given. Second law says that the normal line incident
Is
incident ray,
perpendicular.
normal, and the reflected ray, all of them lie in the
Have the same
same
surface.
plane,
Yes, sir.
right? So suppose you have this mirror and you draw a hypothetical plane here. Okay, so the incident ray, normal, and the reflected, all of them will be lying on this plane. Getting it now?
Yes, sir.
The angle of incidence is always greater,
Equal.
smaller, equal, equal.
Equal.
Good, good. Now the angle between the reflected ray and the normal, what do you call that?
Angle of reflection.
Angle of reflection. Okay, Ahmed, you tell me, the reflection of light from a smooth surface is called as what? Is it diffuse, regular, dispersion, or spectrum?
Regular.
Regular reflection. Very good. Okay. What if you were to have a rough surface like this? Then the deflection will be
Used.
diffuse reflection. Good. And the rays of incident ray, the incident ray will be parallel, but the reflected ray will be different directions.
Yes, sir.
Okay, as you can see in this picture, the diffuse reflection, this is how it looks like. This is the diffuse reflection. All right.
Yes, sir.
Now, moving on, we have got 6 more
Sir,
minutes.
I have a
Let's,
doubt.
yes.
Sir, when the light falls on our eyes after reflection,
Mm-hmm.
will the light be the same? Like, will the effect on our eyes will be the same when the reflection is regular or is diffused?
You are saying that when light enters into our eyes, will the reflection be same? Will the angle of incidence and reflection same? Is that your question?
No, sir. See, whenever the light is fallen on a regular surface, it will be parallel. But in
Yes.
diffuse surface, it will be scattered. Will
Mm-hmm.
there be any change when it falls on our eyes?
Yeah, exactly. That's a good question. Look here. In the chapter, in context of light, you have a concept of lens, right?
Yes, sir.
Lenses are curved mirrors. They are
Yes, sir.
curved
Concave
mirrors,
and convex.
concave and convex mirrors. Right now, our eyes are also acting as a lens here. Right now,
Yes.
so in the
Yes.
case of lenses, they have got capability to bend the lights. For example, this convex lens, what it will do now, it will bend the light and force them to meet at a point. That is
Yes, sir.
called as focus. You will study in the future
Mm-hmm.
classes. Right now,
Yes.
so same thing our eyes does also. For example, as you have posed the question, let me complete it. For example, this is the surface of the eye. Suppose light are entering from here, right? And that is
Yes,
the
sir.
back of the eye that you call as retina, where the
Yes.
formation of image take place. So this light is coming here and the eyes are having a curved surface that our eyes also act as a lens. So as I said, the lenses can bend the light rays, so it will converge at the retina where the image
Yes,
is
sir.
formed. So that is
Yes.
the your question. I hope it's answered. It's clear, I hope.
Yes, sir.
Okay, now coming back quickly to the plane mirror. What are the properties of the image that is formed in a plane mirror? Plane mirror. So we are talking about properties of image formed by a plane mirror.
So the
Okay,
distance between us and the mirror is also the same inside the mirror. We can see the
exactly.
image distance.
Exactly. The first property is that the image that is obtained in the case of a mirror is virtual.
Yes,
Virtual
sir.
means that it is not actually there.
Straight. Yes, sir.
It is not actually there. That's why you call it as virtual. As soon as you move away from the mirror, okay, or sideways from the mirror, you are no longer to be seen in the mirror. So it's
Yes,
virtual
sir.
there, right?
Yeah.
Okay, if standing in the mirror, if you were to raise your left hand, okay, if you were to stand here and you raise your
In the
left
left
hand,
like right hand.
exactly in the mirror, you will see that you are raising which hand? It will
Right
appear
hand.
as you are raising your right hand. So the
Yes, sir.
next property, no, guys, it says that the image is
It's uh,
laterally
yeah,
inverted.
laterally inverted. Yes, sir.
Okay, laterally inverted. It's not like upside down. So it's not like you will be seen like this, your hands like this, head like here. Getting it now? It's not like
Yes,
this. So it's sideways inversion of image. All right. It's not
yes,
upward or downward inversion. Is it clear?
Yes, sir.
Ahmed Arhan. So that is the image form in the plane mirror is laterally inverted. And the most important is the image is always erect. It is erect. Getting it now?
yes, sir.
Okay. Look at this.
Yes,
Look
sir.
at this figure here. Here, this is your plane mirror here, and
Yes, sir.
this is the object here, and this is the image of the object that you call as virtual image. Why? Because it is not actually there. Okay.
Yes, sir.
Yes, sir.
Right now, and the interesting thing is that the distance between the mirror, distance between the object and the virtual image is what? It is
It's same.
same. So
Yes, sir.
distance
Equal.
from the object to the mirror and distance of this virtual image from this mirror is always same. Right now?
Yes, sir.
Yes, sir.
Right now. So one more property you got to know, that the distance of object from mirror is same to the distance of image from mirror. Right?
Yes,
Okay,
sir.
so with this, I
Yes,
will
sir.
be ending the today's class, and I am giving you two questions for you guys to think. That will be
Yes,
your
sir.
task, and I will be asking to you guys,
Yeah.
and they are very interesting questions. Suppose if you are running towards a mirror with the speed of 2 meters per second, okay,
Yes, sir.
you are running towards a mirror, then at what speed your image will be running towards you? Getting it now? An object
Yes,
is running with the speed of 2 meters per second, then at what speed your image will be coming towards you?
it
Are
will
you
be the
getting it?
same, right?
No, it's not
Yes,
going
sir.
to be same. The second question
Okay.
is that in order to get your full image